Last time, I was on the verge of unlocking spaceships. This time, I launched my very last cargo rocket and build a massive logistics space dock. But first, I max out production modules in core mining, but more importantly have to separate each resource into separate warehouses. It got too complicated to try to shove them all into one. With 4 modules, green ships now get plus 74% per copper. I designed a new spaceship that can land on planets and head to Mars to set up a fuel depot. Sometime later, it has nuclear power, core mining producing a ton of oil, and supplies for a local mall. Most importantly, it has a big plant producing a lot of rocket fuel. Another planet colonized to feed the factory. Pretty soon, I have an automated tanker to haul rocket fuel around the solar system. I exclusively use spaceship for traveling between planets now. Here, I am dramatically boosting my iridium production on Mariel and Beryl on Kotsky. I then use my gunship to start the colonization process of a Vitamelange world. The poor biters have no idea what's coming. With cargo rockets a thing of the past, I design a spaceship hauler. This spaceship on Mariel is loading. The L signal over here from this combinator tells us the state, and while it loads, it shoves all the goods coming into this chest. But the chest is filled, so these belts notice that stuff has stopped moving, and they switch the state to P to prepare for launch. When P triggers, this thing unlocks over here, and all the resources get sucked into the ship, ready for transport. Next signal, launch. And away we go. And we are off to Nauvis orbit, because Nauvis orbit is our new space hub. At my space dock, spaceships come from all of the colony worlds to bring the goods that they specialize in making, to refuel with liquid rocket fuel provided by my oil planet, and then ultimately to bring back goods that they need from elsewhere in the solar system. The hauler from Nauvis specializes in traditional Factorio goods, and especially those that want to use production modules, since you can't use production modules in space. We've got one that specializes in vulcanite and iridite, got one for cryonite, one for beryl. Borum specializes in holmium, but it's still sitting on planet, hasn't made it yet. And mercurial's a new one that I haven't quite finished that will bring Vitamelange. Small quantities of the goods provided by all the colony worlds is stored in this warehouse. From there, they'll make it down to Nauvis if Nauvis needs them, or into the space science factory down below if it requires them. Otherwise, this warehouse provides goods that all the different colonies might need, and these individual belts go to each colony to refill their supplies. If you're curious how this all works, keep watching. You've been warned. To figure this out, I started with something simple, and then something a little more complicated, and ended up with this. Let's talk about storing states. There are 4 states for a spaceship launch, and I use a pretty traditional combinator with a loopback to store the state. This one is empty right now, so how do I initialize it with unload, which is the first state? Pretty simple. This combinator says if everything is 0, then output U. At which point, that's my BIOS. It will initialize the state to U. But that simple BIOS case only worked because it is able to compute the value of U in a single cycle and avoid feedback loops. However, when going from load to prepare for launch, it's more complicated. This one makes sure the ship has enough fuel, which we imitate with this combinator. It makes sure the current state is L, which it is. It then makes sure that there are items backed up on the belt, because we don't send the ship until it's full, and it makes sure that items have stopped flowing here. When that all comes together, it counts up, and once a full second has passed, 2 seconds looks like, because this is a double cycle, it sends green to this guy, who says if the green is 0 because the -1 here offsets the 1, then send the signal. It should send a -1 L and +1 P, which will switch this from L to P. But that's not what happens. We'll load this thing up. The combinator gets high enough, and what's our new state? L-4 and P of 5. That happened because this thing fired off 5 different times. And it fired off 5 times because all the data flows through here, and by the time it gets back out to change the state to P, it's still flowing 4 more times. So we got to fix it. The fix is to add another signal. In this case, we have a clock pulse. It keeps increasing by 1, and we modulo it by 5. That gives us an output that goes from 0 to 4 and back to 0 again. We take that signal and feed it in here so that only on 0 do we get a green light. That green combines the other green, and instead of canceling 1 green, this -2 cancels 2 greens. So in the end, when the state is loading and the belt backs up, the clock ticks up, state changes, and the state changes to just P. And the reason it doesn't go through twice is because this guy only went through on clock 0, and by the time this gets back to 0 again, this state's changed from green to not green because the state is not L. Transitioning from prepare to launch is much simpler. It just has a 3-second counter, at which point it transitions. It still has to use the clock modulo 5 signal. And likewise, launch to unload is just a, well, it looks like a 10-second counter, at which point it goes to unload. Switching from unload to load is only slightly more complicated. It watches the belt to see if stuff is still unloading, and only after it's unloaded and gone for a full second with no more goods does it launch. However, it also needs to make sure there's a ship actually present, and for that, it checks for a ship signal of anchor using left clamp. At the moment, it's still stuck in the unload state because as far as it can tell, there's no ship here. But if we pretend and tell it there is a ship here, it will switch from the unloading back to the loading state. There is a far easier way to keep track of 4 states. Passing a piece of plastic around 4 chests and keeping track of where the plastic is lets you manage these states with no race conditions. I didn't do this because I'm a masochist. The other big challenge is communication. Nauvis orbit streams 7 different signals across the solar system using a single transmitter. I could make 7 transmitters, but what's the fun in that? Sorry, capturing single images from a compressed video stream tends to give you garbage, but these are the 7 signals that we send. This is all driven by a master clock with modulo 60, so the clock goes from 0 to 59 and loops back around again. At clock 0, we send a demand signal. These notes are for me because without them, I would forget how this stuff works. The process is actually pretty simple. We use this combinator to protect the clock signal so we don't pollute it, and this one says if the clock is 0, send the data through, which includes a demand signal plus our actual demand. On clock 1, we send what we have unloaded from ship 14, which is the ship from Nauvis. Like sending demand, we first isolate the clock signal, and if the clock is 0, we send through our signal. This guy, constant, sends a constant -1 clock, so this really sends a signal on clock of 1. It includes unload signal plus ship 14, plus a bunch of data about what our ship has been sending, which I think I track right over here. You'll notice it keeps resetting every time we send more information about what is sent. This process is repeated for every ship, and those are our 7 signals. This receiver gets from Clippo and decodes by looking for a signal with a D of 0. The constant combinator of -1 makes sure the only signal that matches is the actual demand signal. Once that comes in, we latch the data here. Likewise, we look for an unloading signal. If unloading is 0, this passes through, which only happens when unload is equal to -1. And then, with a ship of -16 here, this guy only passes through ship 0 if the ship number is 16. Therefore, the only signal he passes through is unload 1, ship 16. And that comes down here, so we can keep track of what has been unloaded from this ship. We normally keep track of what's been sent in this register. In this case, it's 29 uranium fuel cells, but they haven't been sent quite yet. And this gets reduced as we find out what's been unloaded. That allows us to track everything sent to the remote planet. This pattern repeats on each of our colony worlds, with signals sending information about what is loaded and unloaded from each of our ships. Some ships are busy loading goods to send. Other ships are busy unloading stuff they received. And this is essentially how the space dock works.